Okay, what I want to go over is solving and graphing an absolute value inequality. What I did on the right here with my calculator is when I went into y equals, I'll clear that out just to show you what exactly I did to put in the absolute value equation. What I'm going to do is graph the left side of this equation and the right side, just to help kind of understand what's happening with this graph. So I'm going to hit second 0 and then enter, and then do 3x minus 10, and then close brackets. And over here what I did was we graphed 4 as well. If I go to window, if you have your calculator, you can change your windows basically to get a better look at this graph. So you can take a quick look at that, and here's what we have. Okay, now the straight horizontal line you can see is up 1, 2, 3, 4, and the V here is what an absolute value equation looks like. And basically what this question is asking is, where is this absolute value problem or graph, where is it greater than 4? So if you think of 4 as like water level, okay, where is it out of water? Where is it above the water? Okay, out here, in this region here. Okay, so if you look at this graph, this sort of makes a lot of sense. If I look at right here, we can see that that's going to be 2, and you can use the calculator to verify that, and we'll do that real quick. Second calc intersect, okay, and if you use the right arrow to get over towards one of the intersections, or I'm sorry, the left arrow is what I was using just then. Okay, we hit enter for a second guess, and the intersection is 2, 4. Okay, look at the x value. The x value is 2 there. On the other side, we'll do that. We'll figure that out real quick. Second calc intersect. And again, I'm using the right arrow here on my keyboard to get over to that section there. When you're finding intersections, you want to get as close as you can so that it doesn't find another intersection. So it looks like we got 4 and 2/3. And again, the graph sort of helps you visualize why the answer is what it is. So we'll come over here and we'll go ahead and solve this problem. Um, Basically, when we have an absolute value inequality, we don't have one problem to solve, we have 2. Okay? So what we're looking at is we want to solve 3x minus 10. We want to find out where that's greater than 4, but we also want to find out where 3x minus 10 is less than or equal to negative 4. Okay, now think about that. Why? Because we want to know when the absolute value will be greater than 4. So when will the 3x minus 10 get you numbers like 5, 6, 7, 8, 9, and up? So a lot of people say, well, why do we do less than or equal to negative 4? Well, because we want to know when 3x minus 10 will get you numbers like negative 5, negative 6, negative 7. Okay, because the absolute value of those numbers will be greater than 4. So how do we solve this? I'm going to add 10 to both sides. 3x is greater than or equal to 14. So x is going to be greater than or equal to 14 over 3. Okay, which if we divide that out into decimal form, if you wanted to, we would get 4 and 2/3, or 4.66 repeated. Okay. On the other side, again, if we add 10 to both sides, we will get 3x less than or equal to 6. Divide both sides by 3, and we'll get x is less than or equal to 2. Okay, so you can see this is what we have graphed here, less than or equal to 2. So it's a colored in circle. It's not an open circle. And then x is greater than or equal to 4 and 2/3. So we have, again, a colored in circle pointing up the line. So that was just a quick video on showing you how to solve absolute value inequalities. Again, I think the graph here kind of helps helps you understand it, but if you have a good handle on both, you're in pretty good shape. This one will be a good problem to solve only because a lot of people have trouble when it comes time to flipping the inequality symbol and dividing by negative. So again, what we're looking at is two problems to solve. Negative 6k plus 3 is less than 27, and negative 6k plus 3 is greater than negative 27. So if we subtract 3 from both sides, negative 6k is less than, what was that, 24. And if we divide both sides by negative 6, don't forget, right away, what I always like to do is flip the sign, because anytime you divide by a negative with inequality, you've got to flip the sign. K is going to be greater than or equal to negative 4. I'm sorry, just greater than. Over here, we're going to subtract 3 from both sides. Negative 6k is going to be greater than negative 30. If we divide both sides by negative 6, I'm having trouble with my pen today. Again, the inequality symbol will flip, and we get k is less than 5. So if you look at this value here, k is less than or greater than negative 4. That's why we have an open circle there, and pointing up the line, greater than negative 4. And then this symbol right here, this inequality there, k is less than 5. Okay, can't be equal to, so we have an open circle and pointing down the line. So those are just a couple examples of dealing with inequalities. This video will have a couple problems on my wiki space that'll go with it, with the answers already there, so you can try a few on your own, see if you can get them figured out. Thanks a lot.